Welcome to my channel. Today we're going to discuss one of the most common questions in the LLM application development world, LangChain versus LangGraph. If you've been building applications with large language models, you've probably encountered both of these frameworks and wondered which one you should use. The truth is, they serve different purposes, and understanding when to use each one can make a huge difference in your project's success. In this video, we'll break down both frameworks, compare their architectures, explore their use cases, and give you a clear decision framework for choosing between them. Whether you're building a simple chatbot or a complex multi-agent system, you'll walk away knowing exactly which tool fits your needs. Let's start by understanding what LangChain actually is. LangChain is a powerful framework designed for developing applications powered by large language models. Think of it as a toolkit that gives you pre-built components you can chain together to create LLM-powered workflows. The framework is built around 4 core components. First, we have chains, which are sequences of calls that can include LLM calls, tool calls, and data processing steps. Next are agents, which are autonomous entities that can decide which actions to take based on the input they receive. Then there's memory, which allows your application to remember previous interactions and maintain context across conversations. Finally, tools give your LLM the ability to interact with external systems, APIs, and databases. The beauty of LangChain is in its simplicity. You import what you need, define a prompt template, create a chain by connecting your LLM with the prompt, and run it. The components link together like actual chain links, each one connecting to the next in a predictable, sequential manner. Now let's look at LangChain's architecture more closely. The execution flow in LangChain follows a linear, chain-based pattern. Your input comes in, gets processed by a prompt template that formats it appropriately for the LLM, then the LLM generates a response, an output parser extracts the relevant information, and finally, you get your response. This flow moves in one direction, from input to output, with each step happening in sequence. This is what we call sequential execution. It's predictable, easy to debug, and perfect for straightforward tasks. The key features of this architecture include modular components that you can swap in and out, the ability to easily chain multiple operations together, a predictable flow where you always know what happens next, and one-shot execution where your chain runs once and produces a result. This linear approach makes LangChain incredibly intuitive for developers who are just getting started with LLM application development. Now let's turn our attention to LangGraph. LangGraph is a library specifically designed for building stateful, multi-actor LLM applications that support cycles and conditional routing. While LangChain thinks in terms of chains, LangGraph thinks in terms of graphs. The core concepts in LangGraph are fundamentally different. You have nodes, which represent individual units of computation, like an agent function or a tool caller. Then you have edges, which define the connections and flow between nodes. State is a shared data structure that persists across all nodes and gets updated as execution progresses. And perhaps most importantly, you have cycles, which allow the execution to loop back to previous nodes based on conditions. This is the key differentiator from LangChain. LangGraph supports cycles and conditional logic natively, meaning your application can iterate, refine its answers, and make dynamic decisions about where to go next in the execution flow. This opens up a whole new world of possibilities for complex agent behaviors.
Let's examine LangGraph's architecture in detail. In a typical LangGraph application, you have multiple nodes connected by edges, forming a graph structure. An agent node might make decisions about what to do next. A tools node executes various tools based on the agent's decisions. An evaluator node assesses whether the result meets the requirements. And a router node decides where to send execution next. Notice how one of those edges loops back from the router to the agent. This is a cycle, and it's what enables iterative refinement. If the evaluator decides the answer isn't good enough, the router can send execution back to the agent to try again. This cyclical execution happens alongside a shared state object that persists throughout the entire execution. The state might contain messages as a list that grows over time, context data stored in a dictionary, an iteration counter to track how many times we've looped, and a status indicator showing whether we're still running or done. This combination of cyclical execution with state persistence is what makes LangGraph so powerful for complex agent workflows.
Now, let's put these two frameworks side by side to really understand the key difference. On the LangChain side, you have a straight linear flow. Input comes in, goes through processing, hits the LLM, and produces an output. It's a one-way street with no looking back. This is one-shot execution at its finest. On the LangGraph side, things work differently. You start at a node, move to an agent, go through evaluation, and here's where it gets interesting. Based on the evaluation, the flow can either proceed to the end or loop back to the agent for another attempt. This is iterative refinement, and it's incredibly powerful for tasks that require multiple attempts to get right. Think of it this way. LangChain is like following a recipe step by step. You do step 1, then step 2, then step 3, and you're done. LangGraph is more like a chef who tastes the dish, adjusts the seasoning, tastes again, and keeps refining until it's perfect. The choice between them really comes down to your use case. If you need predictable, straightforward execution, LangChain is your friend. If you need adaptive, self-correcting behavior, LangGraph is the way to go. Another crucial difference between these frameworks is how they handle state and memory. In LangChain, memory is handled through various memory classes. Conversation buffer memory stores the complete conversation history, which is great for short conversations, but can get expensive for long ones. Conversation summary memory automatically summarizes past conversations to save tokens, and vector store memory uses semantic search to find relevant past interactions. These work well, but they're essentially bolted on to the chain structure. In LangGraph, state is a first-class citizen. You define your state as a typed dict with strongly typed fields, which means you get better error checking and code completion. Checkpointing is built in, so your state is automatically persisted and can be recovered if something goes wrong. State channels with reducers give you fine-grained control over how state updates are applied. Think of LangChain memory like a notebook where you jot down important things to remember. It works, but it's separate from your main workflow. LangGraph state is more like a shared whiteboard that everyone can see and update in real time, with changes tracked and persisted automatically. For complex applications where state consistency is critical, LangGraph's approach is significantly more robust. So when should you reach for LangChain? Let's go through the ideal use cases. First, simple question and answer chatbots. If you're building a conversational interface that takes a question, looks up some information, and returns an answer, LangChain is perfect. The linear flow matches the straightforward nature of the task. Second, document summarization. Taking a long document, processing it through an LLM, and producing a summary is a classic chain operation. Input goes in, summary comes out. No loops needed. Third, retrieval-augmented generation, or RAG applications. This is actually one of LangChain's strongest use cases. You retrieve relevant documents from a vector store, stuff them into a prompt, and generate a response. The chain abstraction maps perfectly to this pattern. Fourth, quick prototyping. When you're just exploring an idea and want to get something working fast, LangChain's simplicity shines. You can go from zero to a working prototype in minutes. The common thread here is that all of these are linear, predictable workflows. You know exactly what's going to happen at each step, and there's no need for the execution to loop back or make dynamic routing decisions. Let's look at how the code differs between these two frameworks. In LangChain, you import your chain class and prompt template, define the template, create the chain by passing the LLM and prompt, and then run it. It's declarative and concise. You're essentially describing what you want to happen, and LangChain figures out how to make it happen. In LangGraph, the approach is more procedural.
You import state graph and define your state schema using typed dict. Then you create the graph, explicitly add nodes with their associated functions, and wire up the edges between nodes. Finally, you compile the graph into an executable application. The LangChain approach is simpler and faster to write. The LangGraph approach requires more setup but gives you much more control. Looking at setup complexity, LangChain is relatively low. A few lines of code and you're up and running. LangGraph has higher initial complexity because you need to define state, create nodes, specify edges, and handle the graph compilation. However, that upfront investment pays off when your application grows in complexity. The graph structure scales much better for complex workflows than trying to chain together increasingly complicated chains.
Let's wrap up with the key takeaways from this comparison. LangChain is linear, component-based, and great for RAG applications and simple workflows. If you're building something straightforward, it gets you up and running fast. LangGraph is cyclical, stateful, and ideal for complex agent systems that need to iterate, self-correct, or manage sophisticated state. And here's something important to remember. These frameworks can work together. You can use LangChain components inside LangGraph nodes. They're not mutually exclusive. Looking at the feature comparison, LangChain excels at simple chains while LangGraph handles cycles and loops. For state management, LangChain offers basic capabilities, while LangGraph provides advanced typed state with persistence. And for multi-agent systems, LangGraph is the clear winner. If you're preparing for an interview, remember this. The key is knowing when to use each framework based on your application's complexity. Interviewers love to hear that you understand the trade-offs and can make informed architectural decisions. If you found this video helpful, please like and subscribe to the channel for more AI engineering content. Thanks for watching.
Let me give you a practical decision framework to help you choose. Start by asking yourself, what type of LLM application am I building? The first question is, do you need cycles, loops, or conditional branching in your execution flow? If yes, go with LangGraph. There's really no way around it. LangChain simply doesn't support cyclical execution natively. If no, ask the next question. Is this a simple, linear workflow? If you're building something straightforward where data flows in one direction, LangChain is your best bet. It's simpler, requires less code, and is easier to maintain for basic use cases. But if you answered no because you have multiple agents or complex state requirements, even without explicit cycles, LangGraph is probably still the better choice. Its state management and graph structure will make your life easier as complexity grows. Here's a pro tip. Start simple with LangChain. Many developers successfully begin their projects with LangChain and migrate to LangGraph when their requirements become more complex. The conceptual models are similar enough that the migration isn't painful, and you get the benefit of faster initial development.
Now, let's look at when LangGraph becomes the better choice. First, multi-agent systems. When you have multiple AI agents that need to collaborate, take turns, or hand off tasks to each other, LangGraph's graph structure makes this natural. Each agent is a node, and edges define how they communicate. Second, complex reasoning loops. If your application needs to think, evaluate its thinking, and potentially try again, you need cycles. LangGraph excels at self-reflection and iterative improvement patterns. Third, human-in-the-loop workflows. Sometimes you need a human to approve an action before proceeding, or to provide additional input mid-execution. LangGraph's state persistence and ability to pause and resume makes this straightforward. Fourth, agentic applications with dynamic tool use. When your agent needs to decide at runtime which tools to use, possibly use multiple tools in sequence, and adapt based on the results, LangGraph's flexibility is essential. The pattern here is complexity. These are all scenarios where the execution path isn't known up front, where you might need to iterate, backtrack, or make dynamic decisions. If your application fits any of these descriptions, LangGraph is almost certainly the right choice.